This video will give you a high-level overview of the kinds of questions that you can answer using the Strategic Portfolio Modeling tool, SPM for short, as well as the approach it uses. Subsequent videos will demonstrate actual usage of the tool. An example case study will serve as the backbone for all videos. To understand where the value of SPM lies, let's start by talking about portfolio management. Typically, this involves making a decision today concerning the assets or projects that we have in our portfolio today. Typical decisions involve which assets to pursue and which to discard, or how to allocate constrained resources. And we use some process to make such decisions. Subsequently, as time passes, the composition of our portfolio changes. Therefore, at some point in the future, we will repeat the process in order to make decisions concerning whatever assets will be part of our portfolio then. By comparison, long-range planning is concerned with understanding today the impacts of applying a process repeatedly over a long period of time. The process may in fact be a portfolio management process, but it may also concern budgets, resources, or partnerships. SPM is a long-range planning tool that explicitly accounts for time by simulating the progression of a pipeline-based portfolio. To get a better understanding of this, let's look at an example. Suppose your organization develops drugs in 6 different therapeutic areas and has some information about what it takes to develop an asset from each of these areas. For now, let's focus on the clinical and regulatory phases, abstracting away the preclinical process, and assume that each year 2 new drugs from each therapeutic area will reach phase 1 for a total of 12 phase 1 entrants per year. Here is an Excel file with the information we have about the therapeutic areas broken down by phase 1, 2, 3, and regulatory. For each of these phases and for each therapeutic area, we have cost in million, cycle time in days, and probability of success in percentages. If we focus on the probabilities of success, we can gain some insights on the outlook of the organization. Multiplying the per phase probabilities for each therapeutic area and then averaging over the areas, we obtain about 20% of all assets entering phase 1 would get launched. If we have 12 entrants each year, that's an average of 2 to 3 launches per year. However, this doesn't tell us how much fluctuation in the number of launches we could have from year to year. For instance, are years with no launches atypical? How about really good years with 4 or more launches? Computing average yearly cost is more complicated than launches due to the heterogeneity of cycle times across phases and therapeutic areas. And there is still the question of how much fluctuation around that average there would be from year to year. And if, in fact, some years your budget is not enough to work on all assets and you consistently use some portfolio management process to decide which assets to pursue, how will that process impact your long-term yearly launches profile? What if you were to tweak that process? Could you get more launches with the same amount of money? And what if you were to make some deals and partner some assets? Would that be worth your while? SPM helps answer questions such as these and many more by simulating the development pipeline as the complex dynamic system that it is with many interacting parts. Here is a graphical depiction for our example. We have the 4 phases of interest and the therapeutic areas. For simplicity, I've drawn only 2. Think of them as streams from which assets flow into the pipeline. At any given time, the portfolio will contain a mixture of assets coming from different streams, depicted here by molecules with different background colors, and these assets will be in progress in various phases. Depending on the phase it's in and the stream that it comes from, each asset will have different properties such as cost, probability of success, etc. And all assets in the portfolio use a common pool of resources. SPM models such elements as phases, streams, assets, and resources, and simulates the processes and events that assets undergo over time. Specifically, during each time step, an asset can enter the pipeline via some stream, be resourced or de-resourced. If resourced, it will consume resources and move along in its current phase. Otherwise, it will be put on hold. The asset may reach the end of the current phase, at which point a coin is flipped, biased by the asset's probability of success for that phase, to determine if it fails and exits the portfolio, or if it advances to the next phase. If the asset is on the market, it will collect revenues. If it has reached patent expiration, it exits the portfolio. The asset may also be thrown away or have its properties changed due to some strategy. In a subsequent video, we will go over SPM's natural and fast way to transform strategy descriptions coming from high levels of the organization into rules that can actually be used in a simulation. While running the simulations, SPM collects data about all the assets that passed through the pipeline and the events that happened to them. This data is then aggregated into reports on financial metrics such as costs, launches, revenues, net present value, or productivity metrics such as resource utilization. The reports can range from very specific to very generic because the collected data can be sliced and diced based on a multitude of asset properties. Now that you have an idea about what SPM does and what it's for, in the next video, it's time to see it in action on our example case study.